The Mississippi River's delta building forces began to shape North America while dinosaurs were still roaming the earth. During that time, temperatures and sea levels were high enough that a seaway sat on top of the continent. This epicontinental seaway began to move as Pangaea was splitting into the continents we see today. This caused the young Mississippi River to follow the path of least resistance to the south, forming the first stretches of land. The river deposited sediment and land began building from the tip of Illinois all the way down to Louisiana's Birdfoot Delta. Occasionally, the river would overtop its banks and form a shorter route to the Gulf, which usually became the preferred channel over time. This process occurred naturally for millions of years until humans began altering the landscape with levees and canals. Today, the Mississippi River carries an average of 436,000 tons of sediment every day. As that sediment is brought down and deposited, it physically builds new land. The impact that this sediment deposition and human controls have had on the east and west banks of the lower river is visibly noticeable and of great importance to the stability of the ecosystem and the communities that it protects. Did you know that having a healthy marsh is critical for protecting the land and communities located behind it? For every 2.7 miles of marsh present, storm surge height is reduced by 1 foot. These protective marsh barriers are crucial for us to continue living in coastal Louisiana, which is why we must work to rebuild and protect our wetlands. Through the Coastal Wetlands Planning, Protection, and Restoration Act, or CWPPRA program, federal and state agencies partner to oversee projects across coastal Louisiana using a variety of different strategies. The Delta Management at Fort St. Philip, or BS11 Restoration Project, located on the east bank of the lower Mississippi River, is sponsored by the United States Fish and Wildlife Service and Louisiana's Coastal Protection and Restoration Authority. This crucial project utilizes terraces to capture sediment-rich water, restoring the region's marshes. In counterpoint, on the west bank, the levees that are used to prevent flooding of populated areas also prevent the natural flow of sediment-rich water that would periodically flood the marsh and build new land. What geologic processes contribute to delta formation?